So let's continue looking at section 3.5, rational functions and their graphs. Last video, we looked at finding the denominator of the function h of x. So one of the things that I want to point out about this function is that when we put it in factored form, you probably noticed that h of x had a factor of x plus 6 in the numerator and a factor of x plus 6 in the denominator, as well as a factor of x minus 4 in the denominator. You probably had the undesirable urge to do something like this. What I want to remind you about is the fact that most people say we're canceling out the x plus 6. That's actually not a good way to think about what you're doing. What you're actually doing is dividing. You're dividing the numerator by x plus 6 and the denominator by x plus 6. And remember, you can only divide by x plus 6 if it's not 0. So when I divide the numerator by x plus 6, I'm left with a 1 in the numerator. When I divide the denominator by x plus 6, I'm left with 1 times x minus 4. So the result is 1 over x minus 4. And remember, I could only do that division if x was not equal to, if x plus 6 was not equal to 0, which basically means, as we found and as you see above, that x is not negative 6. It's important to keep in mind what we just did was divide out this common factor. We cannot divide by 0, so h is only equal to 1 over x minus 4 if x plus 6 is not equal to 0. Now normally what you see that I've written here, this condition, if x plus 6 is not equal to 0, will not be something that we write, but it will be something that has to be true. So when I eliminate this common factor of x plus 6 by dividing numerator and denominator by x plus 6, I have to keep in mind that the process that has occurred is division, and I can never divide by 0. So what was I dividing by? X plus 6. In order for h to equal this result, what I have divided by cannot be 0. Now I want to point out that what this is telling me is h, which was x plus 6 over x plus 6 times x minus 4, is the same as 1 over x minus 4 everywhere except where x plus 6 is 0. That's the only place where these two functions differ. So what actually happens when a function has a common factor that involves the variable in both the numerator and denominator is that at the value where what you divided by, when you divided that common factor out, at the value where that factor would have been 0, as you can see in our work above, that would have happened at negative 6. So at x equal negative 6, h of x has a hole in its graph. And this always happens if there is a factor in the numerator that involves the variable that same factor is also in the denominator of the rational expression. So we want to talk about what happens in general. A rational function, h of x, has a hole in its graph at x equal to a if h of a has the form, or let's just say h of a equals, so you substitute a in place of all your x's, and the result is 0 over 0. If that form happens, then at x equal to a, there's a hole in the graph. So the important thing to keep in mind here is that I'm going to actually give this function a name. Okay, so we have our h of x So h of x is x plus 6 over x plus 6 times x minus 4. G of x is 1 over x minus 4. Now remember, these two functions equal each other, so h of x equals to g of x if x is not negative 6. So remember, we said x plus 6 can't be 0. Well, x plus 6 is not 0 if x is not negative 6. So I want to show you what this looks like, how these two functions are related. So let's take a look at a graph of these two functions. So here's the graph of the function g of x, which was 1 over x minus 4. Now here's a look at h of x, which was in factored form x plus 6 over x plus 6 times x minus 4. What I want you to notice is that these graphs almost look identical, but there's one place where they're different, and that's when x is a negative 6. H of x has a hole in its graph there. G of x does not. So that's the only place the two graphs are different. At all other values, the two graphs look exactly alike. They have the same points. But when x is negative 6, h of x has a hole in its graph. G of x does not.